Basic OSPF configuration. Want to know one of the most wonderfully frustrating things you can do? Mentor your family into networking. My brothers are actually 10 years younger. Well, one of them, and the other is 13 years younger than me. So I kind of got to see them grow up. And now they're into their careers and things like that. And of course, I'm trying to get them into the IT world, which is wonderful because they have gone that way. But as they look to me for help, I'm the guy they call at 2 in the morning when everything's down. I'm like, oh, seriously? Really? It just happened to me last night. I'm getting text messages from my phones by my bed. Bzz, 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 bzz. It's on mute, but it's just the texts are constant coming through. Help, bail me out, help me out. So I get on the phone with my brother, and I go, oh, okay, so what's going on? Well, it's always everything's down. I don't know what happened. We were just doing a VLAN, and so he's kind of unpacking this, and I'm going, okay, so where's your change log? I don't really have one. And at 2 in the morning with family, I mean, you and I are kind of talking right now, and I'm pretty happy and friendly. But when it's family and it's 2 in the morning, you're like, what? What do you mean there's no? Didn't I tell you? What? I know. You told me. You told me to do that, and it just got sucked in, and I didn't. Okay. Where's your network diagram? What am I looking at here? Well, you know where this is going, right? So I'm coming off one of those experiences into this nugget right now, talking to you, and I want to make sure that you catch. We're going to go through right now the configuration of OSPF, and I want to convey that I'm giving you the core of the skills that you need for OSPF, but there's a whole lot of type A-ness that you need to be. Now, I know some of you are like, what do you mean type A? Type A personality, organized, planned, efficient, that kind of thing, which I'm not by nature. I am not a type A person, but I've had enough of those 2 a.m. experiences, just like my brother has had now, that I'm like, okay, I need to be a little more planned. So just know when you're watching me go through this, and I'm like, okay, let's wing this here. Oh, let's try this out. I'm feeling so fancy free and good because I know, number one, I'm doing my favorite thing, which is talking to people about how to do it. But number two, I know if I misstep and I blow something off, or blow something not off but up, that it's probably going to result in a good learning experience, rather than having a bunch of angry people where their network just went down and their business crashed because you took the very fabric of what runs them out from underneath them, right? So welcome to basic OSPF configuration. Our goals as we start in here is really just to get the core of OSPF down, configuring OSPF on iOS and iOS XR, which will be the service provider core routers, configure OSPF authentication, and then verifying everything works. Let's take a look at the diagram itself and just get our bearings. What we have here is an atypical service provider diagram, right? Over on the left-hand side, we have the core devices going down to the provider or P devices, down to the provider edge devices, which actually feed into the customer. So we see a whole bunch of routers here, but I mean, one of the things that I know can be frustrating is like, well, give it to me. What does this mean besides a whole bunch of hockey pucks on a picture? So let's kind of do like a little, hang on, let me hide this objectives. Let's do a little Where's Waldo sort of diagram here of places. So we've got the provider edge router, which very well could be a managed router. Maybe this is managed by us, the service provider, feeding into a customer or a group of customers, maybe an office complex. I mean, we don't know based on this diagram, but essentially this is our customer. And we are either handing off service directly to them, like they connect up to their switch here, and then their devices and servers and clients and all their different VLANs and IP phones and everything are kind of feeding into this provider edge router, which then trunks them back into, I said trunk, but I'm not talking layer 2 switching. I'm talking connects them back into the provider router. So P2 in this case, as we're diagramming right here. So this could be, I mean, what is this picture? It could be some copper cable that gets them there. This could be some fiber optic cable. We're not sure, again, based on the diagram, but this is kind of how the connection looks. Now, where is this provider router? Well, this might be in the service router POP. So this is the POP, and up above him is the second provider router. And it's not just, you wouldn't just have, P1 and P2 connecting to PE1 and PE2, you would have a whole bunch of customers coming off of these guys, right? Maybe even some redundant customers. You've got PE55, which connects into both of these guys. So if you ever lose a link, or maybe PE55 and 56, one that comes up here, one that comes down here for a true redundant connection to that customer. I mean, there's many options that you could do, but you see what we're doing. We're essentially taking the customer and getting them into our network, which now this could be in the same facility as our core devices. Or they could be different facilities. I mean, this could be then fed into a Sonnet ring that eventually reaches the service router core, or maybe these are the core devices for the POP. I mean, maybe they exist right in the same facility, so we've got this crazy cool connectivity like you see here on the screen. And Core 1 and Core 2 essentially terminate the POP, and they're the ones that then feed into the Sonnet ring, which goes back to the carrier's larger facilities. I mean, we're really talking about many different options that could be based on the size of the carrier, right? But I always want to start that way because sometimes I know it's happened to me. I go through the configuration, I'm like, woohoo, I got OSPF running, but I just feel like something's missing. And what I felt is missing so often is just that bigger picture of how is this all connected to the customer? All right, well, let's get going. Bring PE1 into the screen. Do my all-time favorite command, show IP interface brief. And we can see that we have two interfaces assigned, just like we're seeing in the network diagram. We've got serial 000, which is assigned 192.168.1.2. And then we've got loopback 0, 192.168.1.1, which is this test network. It's a loopback because it's a test network, right? So I've got PE1. I want to configure it first for OSPF. Global config mode. Router, you then pick your protocol. OSPF is what I want to run, and the process ID. It is just a number. Pick a number. Any number will do. I always choose 1. I've honestly never, maybe if I was demonstrating something funky, but never used anything other than 1. Does it have to be the same on all the routers? No. Do you want it to be the same on all the routers? Yes, because otherwise you have to remember them all. Can you run multiple OSPF processes at the same time on the same router? Yes. Would you want to do that? No. So just some common questions I get about that process ID. I mean, can I just say, just type 1? And all questions will be answered there, right? So now we'll, on PE1, let's enable OSPF, I'll say the traditional way, right? Very, very traditional. It is the network command. And I will say the traditional way is likely going away. Likely it is going away because it's confusing. Cisco has a better way of doing it that I'll show in a second, but you do want to know the network command because it does two things for you. One, it turns on hello packets, which really means it's trying to form neighbor relationships on any network. You know, I'll type in, 192. And by the way, it just says what network do you want to put in here? 192.168.1. Let's just go 1.0 is the network. So hello packets forms neighbors. Second thing it does is advertise that network. So that way I can let other devices know about 192.168.1.0. Now, the reason this command is so confusing traditionally is because when you type in 192.168.1.0, immediately people go, oh, okay, so that's the number that you type in there represents the number that you're trying to, or the network you're trying to advertise. Is that true? No. I mean, yes, kind of. See, I'm confused because this command, the network command, is really just there to identify the interfaces. Let me just give you some examples. I could type in network 192.0.0.0 and it would work. Now, a lot of it's going to be based on what I type in as the wildcard mask, which we'll talk about in just a second, but that would work. I could type in 192.168.0.0. So hang on, let me ask some questions here. Does this mean it would advertise the network 192.0.0.0? No, it does not. It's an identifier. It's going to look around for interfaces starting with 192, and it's going to, number one, send hello packets on those interfaces. So hello, 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 hello. Nobody's listening because it's a loopback. And then it's also going to advertise that network. It's going to say, okay, I've identified 192.168.1.0 because that's the network, right? Not 192.168.0.0. That's not the network. That's just saying look for things with 192 at the very beginning. Or this is saying look for things 192.168. Now you might say, well, how do you know? Well, right now I'm just kind of making it up because I haven't typed in the wildcard bits. This is what really tells OSPF what to do. Meaning, how does it know to look for 192 and not, for instance, look for 192.0? How come it's not using that as a significant bidget? I just can't talk. Bidget. So this isn't good. So the way it does that is by the wildcard mask telling it so. So I can come and do 192.0.0.0 followed by a wildcard mask of, follow me here, 0.255.255.255. Looks like a messed up subnet mask, and really it kind of is. But what it's doing is saying, what do you want to match? So this says, I want to match 0 being my match bits. It didn't make much sense. So essentially, wherever you see a 0, think, look at this. Look at me. Right? Wherever you see 255s, actually, can I make these a different color? I can do that, right? 255 says, falling out here, ignore X. Oops. X right here. This 255 lines up to this one, X. You see what I'm doing? I'm trying to squeeze into that bottom there, X. So 255 says, I don't care. Can see that one a lot better, right? I don't care what this is. So this is what says, look at me, 192. So look around. The router then says, okay, I will look at all my interfaces and find anything starting with 192, of which I found one, and then I will do this, and I will do this for that interface, right? Now, I could go another route. I could go in here and say, well, how about I do 192.168, or actually, how about, what if I did this? 192.0.0.0.255.255. What would that do? Nothing. I mean, well, I guess it would do something, but nothing useful for us, because what it's going to cause to happen is the router will say, I'm looking for any interface that starts with 192. Look at this. Has a second octet of 0, right? And then I don't care for these last two. So X these out, right? So it's going to look around and be like, okay, you start with 10, you're out. And then it's going to say, well, oh, 192, ooh, I scored there. Oh, sorry, that's not a 0. So I'm not going to send hello packets and advertise that network, right? So again, this network is what it's focused on, but 0 didn't line up. So you see, it's just a matcher. Can I use that phrase? It's a matcher. It's looking around at the interfaces to try and match them. Now, what is Cisco's best practice? Let me show you. 192.168.1.1. Why? Because that's the exact IP address of the interface. We identified that when we did the show IP interface brief, right? 192.168.1.1 with a wildcard mask. Come on, who knows it? 0, 0, 0, 0. Saying, look at this exactly. Identify 192.168.1.1. Line them all up right there, and you've identified it exactly. Does that mean that it's going to advertise 192.168.1.1? No, it does not. It's still going to look, and it's still going to say, oh, this is this network, 192.168.1.0. It's just an identifier. Why is Cisco saying that's the best practice? Because they do. Because they are identifying the most specific way they can. That way you don't accidentally, like if you did 192.168.0.0, you could accidentally advertise networks into OSPF. Maybe there's secret ninja networks over here that you don't want to advertise, but you accidentally do because you typed in 192.168 or 192.0.0.0 with that broad wildcard mask. Hang on, let me just follow this up. Last thing I'm going to do is area followed by the area number 0. Right? In this series, we're going to talk about single area OSPF, which is, that's why I called it basic OSPF configuration, which is absent of summary routes. Doing multi-area OSPF is actually not too bad at all. It's just a whole bunch of terms you've got to throw in there and learn. You might remember that from the OSPF concepts nugget that I did at the very beginning of that one. So that now is running 192.168.1.1. Now, where I was going is you could do the ultimate dirty network command. Me and my words that I'm using today. The ultimate dirty network command, here's what I'm saying. 0000 as the network with a wildcard mask. Who knows where I'm going? 255, 255, 255, 255. What does that do? That says add everything to OSPF, every interface, because essentially it looks at it and says, I don't care, I don't care, I don't care, I don't care. You put something there, but I don't really care what you put there because I'm going to throw everything into the OSPF system that's there now, and down the road when Bob adds a network, bam, it automatically goes into the OSPF system. You don't want that because too many unpredictabilities can happen in that sense. So we're just going to do network 10.1.1.2. 0, 0. So this is the other side. So again, we're now going to start sending hello messages on that interface and forming neighbor relationships along with advertising this network to other people. Now this guy doesn't care. He's like, yeah, I don't care about 10.1. I'm connected to it, but I do care about this because I didn't know about 192.168.1, right? So area 0. Everything's area 0 in this nugget. Good. I like having this this other kind of mirrored set of equipment down at the bottom because I can do one with full explanation and then I can do one really fast. So config T, router OSPF1, network 192.168.2.1, I think is the IP address. I don't know why I would have given it anything else, but I'll verify it. And network 10.1.1.6 on PE2, that's its serial interface, 0.0.0.0, area 0, right? That's all there is to configuring OSPF, show IP interface brief. It's all in the concepts, knowing the concept. So we've got 10.1.1.6, 192.168, 2.1. Make that a little bigger so we avoid that word wrap. There we go. Okay, so now let's jump over to PE1. And what I'm going to do here is kind of show you the new way of configuring OSPF. Now, this isn't an iOS XR router, but it's going to use a new way of configuring OSPF, and that is under the interface. I should say newer way than the traditional way I just showed you. What you do is go under global config mode. We'll do router OSPF 1. Same thing as before. This is now P1, so I'm up here at the SAD router. And that's it. Well, let me throw one more command just for grins. You might remember I talked about the router ID in the concepts nugget earlier in this series, where I was talking about how it's you want to know the name. The router ID is going to be the highest IP address on a router by default. Matter of fact, I'll do a show IP OSPF on PE2 that we just configured, and it says I'm a routing process OSPF 1 with the ID 192.168.2.1. You see that this router looked at all its interfaces and picked the highest physical interface as well, actually highest in this case loopback interface as the router ID. Loopback interfaces always win, right? But the best practice from Cisco says set it, hard code it. Why do you want it to change as you add interfaces potentially? Why don't you just go in there and type in a router ID? Now you don't have to do that, but boy, that just makes you feel warm and fuzzy. Now I'm not using the network command, so I'm going to go into well, let's do a show IP interface brief because now instead of needing to know the IP addresses, I want to know what interfaces I have. So P1 has serial 2/0. I'm going to go under there. I'm going to type in IP. Well, there's going to be a lot of stuff here. OSPF. Notice up here, process ID 1. What I'm doing is I'm saying I want to add it from the interface perspective rather than using the network command from the OSPF router perspective. Oh, so much better, isn't it? Isn't that good? I mean, you just go in there and identify this interface is going to run OSPF, and it does the two things right here. It says, okay, well, you went under serial, this is serial 2/0, right? You went under there, and you told it it's going to be a member of this, so I'm going to send hello packets, and you can see it did that quite well, did its job, formed a neighbor relationship, and I'm going to advertise this network, 10.1.1.0/30, in all my network advertisements. Isn't that cool? So that's, I mean... I'm questioning. I'm like, why did I even show you the traditional way? Because it's so much easier to do it this way. So interface, fast Ethernet, 1/0, IP OSPF. Maybe because you'll be on an exam and the simulation doesn't support this way. How about that? Or you're using a really old version of the iOS in the real world and it doesn't support this way either. So I like that way. And by the way, in IPv6, that's the only way you can turn on OSPF. There is no network command. Okay, so P1 out of the picture, and P2 comes into the scene. So again, let's use the same super ninja fast method. Show IP interface brief. Let's go into global config mode. Interface serial 2/0. Oh, hang on. Let's do router OSPF. I got too excited. Let's do router ID. Let's set this guy to 2.2.2.2. By the way, if you forget to do that from the onset, once a router picks its router ID, it does not change until you reboot the router or restart the OSPF process. So that's one of those commands. Usually order doesn't matter on the commands on a Cisco device. That one kind of does. So let's go back under interface serial 2/0, and I will do IP OSPF 1, area 0. And that should form a neighbor. It does. So we can see I formed a neighbor with, who is that? That's PE2 over there. So P1 and PE2 have just become friends. I'll go under interface fast Ethernet 1/0, hit the up arrow, do that same command, and we're now running OSPF there to the core, but we haven't introduced the iOS XR yet. Now, I've got this little Crissity Cross going on. What was that? Was that like hip hop for Cisco routers? Crissity Cross going. I'm not going to configure this for this nugget. Just this is basic OSPF, so I don't want to introduce even more links that just add complexity. So let's go to the core devices. I like these devices most of all, not only because they're big and loud and mean. Kind of devices running iOS XR, but I just like you can kind of feel from the very traditional as it evolves, Cisco just coming to more and more of a ease of configuration. So iOS XR, right? I'm going to go into global config mode, and everything lands under the router OSPF configuration. So watch this. I'm going to do router OSPF. So I mean, same kind of thing. We can type in a name instead of a process ID, which is more fun. I'll still use one though, because that's what I've always done. And then from there, we have all of our OSPF configurations kind of segregated into this little section. We don't have to go out under the interface and add the interfaces over there or use network commands, which are big and confusing. Instead, I can say, you know what? I'm going to go in the area 0 configuration mode and add some interfaces to it. So I actually, matter of fact, I even, let's see, what's the best way to do this? Let me just click, hide all these guys. I threw out another diagram where I put the interface labels on there. So you can see the core 1 device. I've got gig 0/1/0/1, and then down here connecting the two, gig 0/1/0/2. So I'm going to bring that guy back into the picture. Let's move it up just so I can see, because again, we don't have to type in network commands. I'm just going to type in interface followed by gigabit Ethernet. That'd be 0/1/0/1, which should form the neighbor relationship over with P1. Now, question for you there. How come the neighbor didn't form? Any thoughts? Any thoughts? Come on. For 200 points, how come the neighbor did not form? We saw it form whenever we typed in the interface on P1 and P2, but we should be, right, if we played our cards right, we should be running OSPF. How come I'm not writing? Please. Between these two devices. How come it didn't just form? Well, answer, because iOS XR doesn't play that way. iOS XR, you type in the commands, but it doesn't commit them until you type in the word commit, right? We're kind of typing in the abyss right now. It doesn't even know if these commands are valid or if they work. It's just doing a basic syntax parser saying, okay, yeah, that's an acceptable command, so I will take that, but it doesn't actually apply it until we go in there and type in commit. So I'll do 0/1/0/2, right? And let's commit that. So once you type it right, you hit the up arrow, hit enter. Notice now OSPF engages. Bam, right there. Process. I just formed a neighbor 1.1.1.1. I didn't set the router ID on the core 1, but that's okay. And it's formed a neighbor relationship on gig 0/1/0/1. Good. It's gone from loading to full. So we have our first neighbor. And by the way, let's bring some verification in along the way here. Let's go over to P1. I'll do notice he's reporting the neighbor forming 2 to the core. Show IP OSPF neighbor. All right, and it comes up and says, sweet, I've got a neighbor. I've got this guy across the WAN link. This is to PE, hang on, let's get him out of the way. PE1 over there. It's a full neighbor relationship with nothing. Now what's that? Nothing and that. I'll talk about it in a second. It's how long. If only we knew this about our neighbors. He'll be dead in 32 seconds. Well, he's saying hello once every 10 seconds, so this is going to constantly tick down from 40 down to 30 seconds and then recycle as long as you don't miss a hello. And even though this is his neighbor ID, I'm speaking to him on this IP address. That's PE1's address, because there's a difference between the address that I'm speaking to and the router ID, right? Now, what's up with the dash? What's the BDR? That kind of thing. So anytime you have an Ethernet network involved with OSPF, it has this little, why can I not write? There's my pen is out of ink. Hang on. Ink. Oh, I had my thing Hidden. Okay, there we go. Anytime you've got a switch, we'll just say a LAN, with a whole bunch of routers connected to it. You know what? I won't even say a whole bunch, although that's what I'm drawing here. Let's just say this is service provider core, right? This is router 1, 2, 3, and this connects to all your customers. And it's kind of bringing all your customers' networks into this core. Well, they don't form full neighbor relationships with each other, because imagine that madness. Let's say this customer network goes down. He's going to let all his neighbors know. He's going to be like, hey, network down, network down, network down, network down, network. And now OSPF, in the way that it works, that means the neighbor that received that network down advertisement has to let all his friends know. So he's going to be like, network down, network down, network down. And then it's like a firework explode. You know, the grand finale when it's like one goes off and then it's like, brrr, it's just like, bam, bam. Everybody's like, ah, it's down. Dijkstra foresaw the coming of the end, and he said, no, instead, I'm going to designate, here's where it comes from, a router, a designated router, and give him a sidekick. We'll call him the BDR, backup designated router, that if we have a LAN situation like this where we have all these neighbors forming, everybody's only going to form a full relationship with the BDR and the DR. Right? This is going to be the full. Everything else will be considered a two-way relationship. What does that mean? It means I see you. We're compatible. Like we could become neighbors if the situation was right. It's kind of like a weird dating relationship. Like, you know what? I'm committed. I'm committed to these two routers. These guys, you know, your options, but I'm not ready to take that step. So we'll just keep you there in the wing as this two-way neighbor. Now, what does that mean technically? It means I'm not going to exchange routes with you, at least not directly. If I have an issue, let's say this network goes down, I'm going to notify the BDR and the DR. You know, this is my friend, and this is his backup in case the DR dies. And then the DR will be the one that forms the neighbor relationship that disseminates that information. How about we go with management? It just gets ugly if you introduce dating into that kind of scenario. So it's like the DR is the manager, right? You don't want everybody emailing the whole company. You just want to have it go to the manager, and the manager says what's up, right? So with these routers, it's kind of the same thing. Now, on point-to-point network, so why is this a dash? Because point-to-point, we don't need a manager. These guys are like, hey, we're point-to-point. There's no sense in managing. We'll just send everything to each other, right? We're good with that. Whereas this one recognized, aha, this is an Ethernet network. Even though there's only two neighbors, I still go through the election process to pick a BDR and a DR because that's what I do in case there's ever another router introduced into that picture. Now notice P1 is seeing this guy. He's like, hey, I'm noticing that over there you're the BDR. Flutters his little eyebrows there. And this guy's like, well, you notice there's no DR. Well, I bet you C1 if he looks this way. Matter of fact, let's head over there, right? Where did C1 go? There we go. If I do on the XR router, let's do a show. It's actually not show IP because XR is all about multi-protocol. It's just show OSPF neighbor. And I look from his perspective. He's like, oh, I see you 1111. That's P1 right there. And I see that you happen to be the DR for the segment. So see how that works? All right, well, let's hide those guys and bring C2 into the picture and do a flyby of him. Go into global config mode. Notice that his interfaces are gig 0402 and 0401. Let's do router OSPF 1. And we'll do area 0 because we're configuring for area 0. Interface gig Ethernet 0/4/0/1. You know what? I want to show you something. Watch what happens. I'm gonna do interface gig Ethernet 0/4/0/55. Now I can tell you that interface doesn't exist, but first off, it takes it, right? Now when I commit, I'm going to go in there and do commit. You'll think, okay, well I'm going to definitely get an error, right? Actually, no, I'm not, because one of the beauties of iOS XR, and I formed a neighbor, woohoo, is that we can actually configure interfaces that aren't really there. They can go in this phantom config mode to where when that interface is added, or I should say if that interface is ever added, it will just inherit whatever configuration is there. That's pretty awesome because that means you can ship a chassis somewhere or ship a supervisor engine somewhere of the device and configure it even though it doesn't have its interfaces yet. But when they add in the correct line cards, as long as they put them at the right places, then it all just takes the config and starts working. That's awesome. Okay, interface gig 0/4/0/2. Throw another commit on there, and we should now have our whole little neighbor relationship world going. Let's go back out here and do, there's our neighbor that just came up to the other core router, and do a show route. Let's just see what Core 2's perspective is. Okay, this is good. Let's take a look. Actually, we don't even need the interface. I just want the IP addresses now. So from Core 2's perspective, as he's looking around the network, he is seeing, for instance, 10.1.1.0/30 via 10.1.12.1. That would be, it's saying, I'm going to go here, 12.1, to reach 10.1.1.0. That's this one. That makes sense. That's the right way. So it's going to go here, it's going to go here, it's going to go here to eventually reach that network. You can see the administrative distance, 110, the believability of OSPF, the cost that it is to reach that network. And I can see all the way down to the very test network at the very end, 192.168.1.0/24 is reachable. Again, we're taking this path to reach that guy. To reach 2.0 is going to 10.1.2022.2. That's P2. So it's going this way to reach that guy. So this is feeling good, right? We've got a fully connected, full meshed kind of environment between our different devices. Okay. So now let's add an authentication. First off, let's define the why. Why and what. OSPF is very friendly. As you just saw right there, I was able to bring up neighbors just by typing in network commands. Hello packets are exchanged, and bam, I'm exchanging routing information between these different devices, which is great unless that device is evil. Now, okay, why would there be an evil device in the service router core? Well, chances are in the core there wouldn't be, although you can never be too safe. I've just conveyed to you, there was one time I was teaching at a facility where I was doing a live class with with real students, like you're not real, right? But you know what I mean, right? So I had people in front of me. We're doing a demo, and I set up an OSPF router as a demonstration. I had it plugged into the network, and I did a show IP route, and I was like, hey, look at that. There's all these networks that are showing up that I didn't even configure, and I'm scratching my head as the students, here's me up at the podium up here with a little pod of equipment connected to the network, right? And you know where I'm going with this, right? So essentially, the students are like, wow, that's interesting. I'm scratching my head, and all of a sudden, a guy of the training center, the manager, runs in. He's like, the network went down. We're working out, trying to figure it out, and so I'm scratching my head. I'm like, okay. Mysterious networks appear. Mad training manager comes in saying network down. What's the scoop? Well, my router formed a neighbor relationship with the backbone of the training center and advertised. I was actually advertising a default route into the training center, which took the entire center offline because everyone was like, "Oh man, that's a great exit point to the network," which essentially went to my little podium as the quote-unquote internet. So Jeremy smiled, unplugged the router, and continued with his demonstration, never mentioning to the training manager what he had done. But that might be a reason why. Is maybe you have people in the service router arena that attach test devices. I'm not saying it's a good practice, but it happens, right? You're like, I'm in the POP. Let me just plug in this device and do a quick test. Forms an inappropriate relationship and takes the entire POP down. Now we don't want that. So OSPF authentication, usually done to where the end user or untrusted entities could be involved. The beauty of OSPF authentication is it is done on a per interface basis. That's such a good thing because it allows us to pick exactly where we want to turn on authentication, right? If I want to do it here but not there, I don't have to. I can just turn it on an individual interface. So what I'm going to do is I'm going to enable it between these two routers. Not because I don't trust my core or anything like that, but because it shows this configuration on iOS and iOS XR. So let me see if I can find the P1. There we go, good. P1 router. And on the iOS, it's done on the interface. So I'm going to do, well, actually, I can see it right here. It is connected to the core on Fast Ethernet 1/0. So I'm going to go into global config mode, into that interface. So I'll do interface Fast Ethernet 1/0. And I'm going to type in two commands. One, IP OSPF authentication message digest. When I do this, well, hang on, I'm going to do these commands pretty fast because I want to show you something. And then IP OSPF message digest key 1, MD5, and then CBT nuggets. This is the key that I'm going to use, okay? So now I'm requiring authentication on P1, right? But I look, and I haven't configured it anywhere else, and I still see, good, I beat it there. I still see my neighbor. So check him out. He's still a neighbor. Why is that happening? Well, look at his dead time. Your time is short, my friend. Because it's no longer accepting hellos from that neighbor. Essentially, they're still saying hello. He's still like, well, I'm still in a relationship with you. But right about now, he's going to say, you're dead. Your dead timer expired. Meaning I didn't receive any hellos that I recognized as being compatible. And we just lost our neighbor relationship between P1 and C1. So this can be a network disrupting event if you don't do both sides simultaneously. I know you're like, well, how do I do that? Type fast. Or you can get one of those tools like, get a friend doing it at the same time, or get one of those tools like Kiwi Cat Tools. I think SolarWinds bought them. SolarWinds Cat Tools, which can execute essentially a scripted. There's many ways to do it, but it's possible. Right? So I'm going to go now over to the core. Let's go to core 1, who's saying, my neighbor has died. We'll get in there and save the day. Router OSPF 1. Go under area 0, and we will do interface gig 0/1/0/1, which is the one. Hang on, move it over there, right there, connecting to P1. This guy right there. So now notice these sub modes. We're like way deep in OSPF, area 0, interface config, and so under here, this XR's mantra is to keep everything in the same area. So we'll do authentication, message digest, and message digest key 1 MD5. And by the way, you can specify multiple keys. So I can say, well, no key 1 and remove key 1. It'll start using key 2 and things like that. So we'll do CBT nuggets. Right? Now, it's not going to come up until I commit. So CBT nuggets is the shared key, and we should see any moment now. There we go. The neighbor moved from loading to full. We've now reestablished that neighbor relationship because we have the same authentication key. Now, before we wrap up, can I just give you a couple more verification commands? I want to, let's go to P1. There we go, the guy who just reformed that neighbor relationship. So a couple key commands: show IP route, or show route on iOS XR, gives you that routing table where we can see everything that's going on. We've seen that one. Show IP OSPF, very handy because it shows you kind of the protocol as a whole. Big thing is the router ID. You can see, if you hit the space bar, how many areas you're in, how many interfaces you have, how many neighbors have formed within that area. That's kind of handy. I'll say one of the more handy commands when you get into some of the more complex stuff is show IP OSPF interface, because it shows every interface and the specifics of that interface that's running OSPF. The biggest thing that I've pulled from here is the hello timers. You remember when we talked about OSPF concepts, one of the things that had to match between neighbors was the hello and dead and wait and all these different timers. So if neighbors aren't forming, this is the first place I come to make sure that my hello timer and dead timer are matching up between the two, because that's included in the hello packet. Show IP OSPF neighbors. I would say this, and I've shown this command to you, but I would say this is my #1 OSPF command. So this is Jeremy's troubleshooting process, right? I set up OSPF. I'm like, okay, show IP route. Any routes? No. Okay, next, show IP OSPF neighbor. Am I forming a neighbor is my next question. So this is always the second command that I type in. Okay, I don't see a neighbor. Okay, well then what I'll usually do is show run section router OSPF, because chances are pretty good if it's not working, it's my fault. So I'll go in and verify, have I configured OSPF? Is it turned on? Let me do a show run interface fast Ethernet 1/0. Make sure that I've got the correct commands typed in there and I'm not missing something. You know, is the key correct? All that kind of stuff. So if it's still not forming, I call Cisco TAC, because there's nothing. I mean, that OSPF is so basic. I don't want to say so basic, but I mean, really, once you verify your config is good, you verify that the hello parameters are the same, meaning you're not using invalid hello timers or wrong subnet mask. You're in the right area. The key is the same. Oh, by the way, I've had this happen so many times where I copy and paste the configuration and there's a space after the message digest key. Some iOS versions will include that. Some of them say, oh, you didn't mean to do that, and it'll cut the space off, but it includes that. So you'll sit here pulling your hair out, which I've done, and you see that it looks fine, but there's actually a hidden space character after that key. So if all else fails, I will say I've run into that at least 3 times, where I've pulled my hair out and then it grew back, but I didn't know there was a space after the pre-shared key. So check that out. All in all, good description of OSPF. How to configure it, iOS XR, adding authentication, and then verifying the functionality. I hope this has been informative for you, and I'd like to thank you for viewing.